So in this question, you're given that fx is x square plus 3x plus a if x is less than or equal to 1, bx plus 2 if x is greater than 1. So if this function is always differentiable, find a and b. So as you can see, f of x is a piecewise function. When x is greater than 1, it is a linear polynomial. When x is less than 1, less than or equal to 1, it is a quadratic polynomial. So we know that polynomial functions are always differentiable wherever they are defined. So if at all there are some problems for this function f of x of differentiability, they have to occur at x is equal to 1. So at all the points apart from 1, this function is directly differentiable for any values of a and b. So if this function has to be differentiable for all r, we need to make sure that f of x is differentiable at x is equal to 1. So if you can maintain that at all other points, it will automatically be differentiable. So now at x is equal to 1, it has to be differentiable. It's a polynomial function, so we can go from the first principle or our direct method. So f dash at 1 plus is equal to, in the right neighborhood of 1, what is the differentiation of f of x is equal to b, right? What's the differentiation of bx plus 2? b. So what is f dash at 1 minus? In the negative neighborhood of 1. So you have x square's differentiation is 2x plus 3. 2x plus 3 at x is equal to 1, which is equal to 5. So for the differentiation to be equal on the left side and right side, b has to be equal to 5. So we have also seen that whenever you do this process, you also have to ensure the continuity. So let us ensure the continuity. What is f of 1 plus? What is the right limit at x is equal to 1, which is b into 1 plus 2, which is equal to b plus 2. And what is f of 1 minus? F of 1 minus is, you put x is equal to 1 here, 1 square plus 3 into 1 plus a, which is equal to a plus 4. So for the function to be continuous, the right limit has to be same as the left limit. So b plus 2 has to be same as a plus 4. So a is equal to b minus 2, which is equal to 3. So a is equal to b minus 2, which is equal to 3. So b is equal to 5 and a is equal to 3 is the right answer. So you can also do this from the first principles, that is using the basic definition of the differentiation of f of x. So let us also do that for completion, because if you get the question in board exam, you cannot do this process. So let us now see the standard process to do this. So if you look at the standard process, f dash at 1 is equal to limit h tends to 0 f of 1 plus h minus f of 1 by h. Because the right definition is different from the left definition, we'll find both the right limit as well as the left limit. So if you go to the right limit, so limit h tends to 0. So f of 1 plus h, if h is slightly more than 0, 1 plus h is slightly greater than 1. So this follows this rule, greater than 1. So b times 1 plus h plus 2 minus f of 1. F of 1 follows this rule, right? Because at equal to 1 you have this rule. So f of 1 is 1 square plus 3 into 1 plus a by h. That is equal to limit h tends to 0. So you have b plus bh plus 2 minus 1 plus 3 is 4 minus a by h. That is equal to limit h tends to 0. So bh plus b minus a minus 2, b minus a minus 2 by h. So limit h tends to 0. So when h tends to 0, So only the least power of h matters in the numerator and denominator. Or you can directly do this as limit h tends to 0. So if you separate these two, so you get b plus b minus a minus 2 by h. So if this limit has to be defined, this number has to be equal to 0 because the denominator is going to 0. The numerator has to be equal to 0. If the numerator is finite, this limit will go to infinity. So the condition is for this limit to be defined, b minus a minus 2 has to be equal to 0. And if this happens, the value of limit is equal to b. So b minus a minus 2 has to be equal to 0. This is one condition. And the right hand limit is equal to b. Now what is the left hand limit? So what is the left hand limit? Left hand limit is slightly more complicated because you have a quadratic function. So now what is the left limit? So limit h tends to 0 minus. So now f of 1 plus h. H is slightly negative quantity. So 1 plus h is slightly less than 1. So you have to go to this function. So 1 plus h whole square plus 3 times 1 plus h plus a minus f of 1, you have to put 1 in this function. So 1 plus 3, 4 plus a by h. So this a and this a gets cancelled. That is equal to limit h tends to 0 minus. So 1 plus h square plus 2h plus 3 plus 3h minus 4 by h. So 1, 3 and minus 4 gets cancelled. That is equal to limit h tends to 0 minus. So h times h plus 5 by h. So h square plus 5h. So if you take h common, these two gets cancelled, which is equal to 5. That means the left limit is equal to 5. So you have 3 conditions. The right limit is equal to b, the left limit is equal to 5, and b minus a minus 2 has to be equal to 0. So for the function to be differentiable, the right limit has to be equal to left limit. So b is equal to 5 and 5 minus a minus 2 is equal to 0, hence a is equal to 3. So you can see that you got exactly the same answers from both the methods.